All right, so we've spent some time graphing exponential functions. We've spent some time graphing e, and so now we're going to learn how to graph a logarithmic function. So reminder that a logarithmic function is an inverse of an exponential function. Why is that important? Well, that means, remember that when we talk about graphs of inverses, they are a reflection across the line y equal to x. So a couple of these points I'm actually going to point out when we talk about the comparisons between the two different types of graphs. So remember, exponential graphs. In the very basic form, it's just y equal to b to the x. Okay, I'm not talking about a or h or k or anything like that yet. In logarithms, we're talking about y equal to log base b of x. All right, so some comparisons. Think about this. If I were to take b and raise it to the 0 power, I would get 1. And so now my x value is 0 and my y value is 1. That's this point right here on our graph. In terms of logs, we would then use the point 1 comma 0. Think about this. If I had log base b of 1, well, b to what power is going to give me a 1? Well, that would be a 0. Okay, it makes sense. You see it over here on the left. All right, so just a reminder that our inverses, we switch the x and the y. All right, when we graphed our exponential graphs, remember that we had an asymptote occurring here. Okay, and our asymptote in this case was y equal to 0. So now our asymptote is going to be x equal to 0. So it is now going to be this line, okay, versus this line. All right, so just a couple of different comparisons. All right, the last thing before we talk about like domain and range and then actually get into the graphing. When we did our graphing, I essentially gave you 3 points to ponder in terms of your graph for those people that like to use charts. One of them was if I plugged in a b to the -1, so a -1 for my x value, I got 1 over b. Well, in terms of logs now, I have 1 over b comma -1. We see up here that if we did b to the 0 power, we got 1, so 0 comma 1. We already talked about 1 comma 0. And then I said, well, what if you did b to the 1 power? Well, that means it would just stay a b, and so now we're going to have a b comma 1. So just a reminder in terms of those points and how they're going to relate to our graph. All right, also remember that when we talk about domain and range, the domain of your exponential graph becomes the range of the logarithm. The range of the exponential graph becomes the domain of the logarithm. So if you think about like, you know, our graph over here with our exponential graph, we talked about the idea that because the asymptote was y equal to 0, our range was y is greater than 0, and our domain was all real numbers. So now we're going to flip that, okay? Because our graph is doing this, it's going down, it's going up. So now our range is all real numbers, and our domain has to be a value that is greater than 0, okay? All right, so now that can change depending upon our h value. So here's a quick little example. I talked about in the last set of notes that remember that this part here always has to be greater than 0. So if I ever want to find the domain, I am going to set this greater than 0. 12 minus 4x is greater than 0, and now I'm going to solve. Negative 4x is greater than negative 12. I'm going to divide by negative 4. I'm going to remember to switch the inequality, and I'm going to say that x is less than 3. Okay, if you choose a number that is greater than 3, then you're going to get 12 minus a bigger number, which gives you a negative value, and then therefore it doesn't work. Okay, so that's why that is. Now, why is the domain important? Well, remember that the domain is also tied to our asymptote. So if our domain is x is less than 3, then that means our asymptote is x equal to 3. So just keep that in mind. That's important, especially when we get into graphing. All right, so here you go. You got a basic function. There's no negative a value. There's no h. There's no k. So just essentially, how does this work? All right, so if I start with our x, we just got done saying that the domain x has to be greater than 0. That means our asymptote down here is x equal to 0. So I'm going to graph this line right here, and it's going to be greater than, so it's going to be going this way. All right, our range, we said, now becomes all real numbers because it's going up and down. All right, now in terms of graphing, if you like to use the idea of a chart, you can go ahead and do that. I am going to reference this up here. So 1/7, okay, 1 over my b value, b is equal to 7 in this case, will give me a -1. I would always have 1, 0 unless my a value was something else. And then I would have 7, 1. Why is this? Log base 7 of 1/7 is equal to -1. Log base 7 of 1 is equal to 0. Log base 7 of 7 is equal to 1. So that's where my y values are coming from. So 1/7, -1, I'm going to plot here. 1, 0, I'm going to plot here. And then 7, 1, I'm going to plot here. And so now I can see that my graph is doing this. And remember, it's not going to cross the asymptote. Okay. All right, so now my x-intercept, well, I found it. It is 1, 0. Since my y-intercept is not going to exist, the reason for that is because since the asymptote is x equal to 0, my graph isn't going to cross. So therefore, I'm just going to write none. All right, as we move to the other examples, basically all we're going to do is we're going to look at like shifts, what did the h and k's do, so on and so forth. All right, so let's go to page 2. All right, so right off the bat, I see I have an x plus 3. My first thought is I'm thinking about domain. Domain is x plus 3 has to be greater than 0, so that gives me x is greater than a -3. That gives me my asymptote. So now I've got this situation. And so now that, like, I don't even have to think about like, oh, x plus 3, the plus means it actually goes left. If you want to remember that, you can also do that idea. But it, you know, they kind of all ties into place. All right, so now I've got in all real numbers, x-intercept and y-intercept. Notice that because of the shift in the graph, I could basically have both. All right, if you are a one of those people that just likes to use the shifts, remember that we had a 1/7 -1, so now it's just shifting over 3 spots. We had a 1, 0, so now it's just shifting over 3 spots. And then we had a 7, 1, which is now shifting over 3 spots, and we're now here. And so now our graph is passing through these 3 points. Okay, and now I've got my graph. Okay, all right, so for this, my x-intercept, it looks like it's now at a -2, 0. It does look like I have a y-intercept, so I'm going to write it as an exact, and it goes back to what we were doing earlier. My y-intercept is now going to be y equal to log base 7 of 0 plus 3, or just my y-intercept is basically just log base 7 of 3, okay? Let's just get in the habit of finding an exact value. And remember, anytime you want to find a y-intercept, just plug in 0 for x. All right, last example here. Okay, for example 3, I changed the base on this one. Just so you know, you get used to something different. I also have a shift here, and then we have this negative value. All right, so I'm going to again start with the domain. So we're going to have that idea that x minus 2 is greater than 0. So therefore x is greater than a 2. So that tells me that my graph has to be to the right of this. That tells me what my asymptote is. Range, all real numbers. All right. So now we have to focus on this idea of this negative. So remember, what that does is it changes all of our y values to their opposites. So that means that if I had, say like in the last example, a 7 comma 1, I now have a 7 comma negative 1. So essentially our graph is flipping over or shifting over the x-axis. So that means instead of my shape doing this, it is now going to do this. So that's what that negative is going to do. All right, so if you are one of those people that like to do the idea of a shift, okay, you can go back to your originals. So 5 to the 1/5 power, so 1/5 comma negative 1, shifted over by a value of 2. You got 1 comma 0 shifted over by a value of 2. And then you have a 5 comma 1, okay, which is going to shift over by a value of 2, and it comes over here. But now what we have to do is we have to flip them over. So now we have a 1/5 comma 1. We still have a 1 comma 0, and now we've got a 7 comma negative 1. So this is using the idea of shifts. Okay? All right. If you like to use that idea of the chart, okay, I'm going to start in a different spot down here. So think about this. We said that the value here has to basically be a 5, so that way we get that b comma 1. So x minus 2 has to equal 5. So that means x is equal to a 7. So I'm going to do a 7 comma 1. X minus 2 has to equal, well, we want a value of 1 so that we have 1 comma 0. So now x has to equal 3. So now I got 3 comma 0. And notice that so far these points are working. I got my 3 comma 0. I've got my 7 comma 1. We're going to flip all these numbers here in a second because of the negative. Okay, and then so the last part is x minus 2 is equal to my 1/7. And so now if I add 2, I've got 2 and 1/7 is equal to my negative 1. All right. Now, because I have a negative y value, why a negative y value? Well, if I divided everything by negative 1, I would have a negative y value. I have to change these to a positive 1, 0 stays 0, and then this becomes negative 1. So now I've got 7, negative 1, 3 comma 0, and 2 7s comma 1, if you want to use that idea of a chart. And so now you can see the result here. So I showed it both ways in terms of a shift, and I showed it in terms of using your chart. Okay, and why did I choose, you know, my, oops, mistake here, 1/5. Why did I choose a 1/5, a 1, and a 5? Well, remember, because my base is equal to a 5, okay, then that means that my 1/5 is my 1 over b, and then 5 is my b value, okay? All right, so the last part here, x-intercept, I can see that it is occurring at 3 comma 0, and my y-intercept is none because it is not crossing the y-axis. All right, the last thing down here is just a quick little reminder that anytime you have like just simply a log 6, that's the same thing as log base 10/6, that the 6 doesn't have to be, the 10 doesn't have to be written. Anytime you got log E12, you can write that as ln12, that you don't need to have that E. All right, so that is graphing with your logs. Come to class with questions.